Hi everybody, my name is Erin Griffith and I'm the program manager at Fedora. I'm happy to be back this year at MIRL to talk about Fedora and specifically Fedora 6, the migration pathways and tools that we now have available to help get you to the newest, kind of most stable and performant version of the software. So thanks for having me. So as a quick refresher here, Fedora is an open source repository software that's used for the management and dissemination of digital content. It is especially suited for things like digital libraries and archives for both access and preservation purposes. And because of its flexibility, it's also used to provide specialized access to large and oftentimes very complex digital collections of a really wide variety of data types, including things like research and scientific data. So Fedora can store, preserve, and provide this access to any type of digital object. It is agnostic of file type and file format, which means that you can truly put kind of whatever you'd like into it. And I mentioned already its flexibility, but within a Fedora repository, you can model your content however you'd like and use really whatever kind of relationships in whatever kinds of complexities you need. And it does this through support for semantic relationships. You can take advantage and use things like linked data and RDF to build out some different content and object models that are going to meet your specific use case. Also, you can store millions of objects of varying sizes in a Fedora repository without any problems. It works at scale. So one example I can share is that the National Library of Wales is in the final stages of a Fedora 3 to 6 migration for their repository, and that holds approximately 6 million objects. And so far, performance for them is exactly where they need it to be. They're happy with the upgrade and they're happy with the performance of Fedora 6. So Fedora is natively designed to interoperate with other applications and services. You won't often find it functioning on its own. It does require some other components. A lot of people use it for their digital preservation needs or to meet digital preservation criteria. And then they would have a front end attached to it like Islandora or Samvera or some sort of custom front end to deliver the content to users. And then lastly, Fedora has a published API, which in Fedora 6 is mostly unchanged from version 5, which has been super beneficial to anybody that has already implemented the API. So this year, we're actually excited to be celebrating 20 years since the beta release of Fedora version 1.0. Obviously, a lot has changed in that time, but I think that Fedora 6 right now really represents the culmination and the coming together of community feedback and using this to drive design efforts. And what we have with this new version is really serving the community well. It's taking Fedora back to its original digital preservation roots and providing something that people are very happy with. So we are on version 6.4, which was released in June. As you can see, along with that release, there are some additional tools and integration pieces that community members are actively using. But obviously being open source, we don't have an exact count of implementations. But from what's being reported in our Fedora registry, we can say that there are approximately 300 or so known installations of some version of Fedora around the world. And this represents a wide range of users from varying sizes of institutions and institutional types. There's no real way to classify a typical Fedora institution, if you will, which actually is really great because it means that we can learn from all these different use cases and ideally broaden our reach even further and even more. So like I mentioned, in 2021, Fedora 6 was released, and this was really long awaited and much needed. And it was a major rewrite of the software. So in 6, we eliminated the former mode shape backend that existed in Fedora 4, which we learned and we know now wasn't serving the community well in many ways. So we replaced it with a new persistence layer, which incorporates the Oxford Common File Layout, or OCFL, as a preservation standard. So with Fedora 6, you also have available to you extensive migration tooling and documentation. And this is really thanks to an IMLS grant that we were awarded that was intended to help lower barriers to migration and bring users on all older versions of Fedora to Fedora 6. So with it, there's a migration toolkit, an actual migration tool for executing a one-step migration. And then there is a migration validator that can be run after the fact to ensure that all your content is moved over correctly. Fedora 6 also offers built-in simple search, which was not previously available in past versions, and this is available through the HTML UI. We also have real-time performance monitoring capabilities that you can set up as an integration with Grafana and Prometheus. So you can look at how your repo is operating in real time and see if you're hitting bottlenecks and kind of where those are occurring, which is a really great tool that you can take advantage of. And then we also offer some basic metrics collecting. And so it's a simple JSON output, but you can look at what's in your repository, a snapshot at any one time that shows you things like object count by MIME type, byte counts, etc. Very simple metrics, but definitely very helpful. And if you do have a use case where you'd like to see some additional metrics be made available, please reach out, because this is obviously something that we can and are willing to expand upon if people have a need. And then we also have the Camel Toolbox integration for Fedora 6. So Camel Toolbox is a suite of microservices that's going to allow you to harness the asynchronous messaging that's natively built into Fedora 6. So this is just to give you an idea of adoption rates and how Fedora 6 is kind of growing in the community. Again, released back in 2021, and even as late as last year, we really only had less than 10 known institutions either on or migrating to Fedora 6. But today, obviously, you can see that that list is much different, and this continues to grow every day, which is very exciting. So we're very thankful that most of the users on this list are active and around the community and have been more than willing to share and discuss their experiences with us. And this has really helped build a kind of network of support for users. So if you happen to fall into any of these categories and you're not listed on the not listed here, please absolutely reach out to me. We would love to hear from you, learn about your experiences, so we can use that to kind of help guide others. So now I'm going to talk a little bit about the tools that are available. So this first slide is specifically about Fedora 3 to 6 migrations and what we have available. I mentioned earlier on the migration toolkit. So this is really a comprehensive instructional guide that walks you through the migration process step by step. So it was developed as part of that IMLS grant. It was built by an instructional designer. So it really is intended to be very user-friendly. It's the step-by-step instructions in a module format. And in it, you can also find contributions from our two really wonderful pilot partners, so the University of Virginia and Whitman College. They contributed back to the project their user stories, best practices, templates, lessons learned, etc. So there's lots of very detailed and helpful information in this toolkit, and that is all available at any time to anyone on the Fedora Wiki. Also developed as part of the grant is the migration utils, which is a tool for executing a migration from Fedora 3 to Fedora 6 directly in a one-step process. And so that is maintained on the FC repo extensions GitHub, and it's linked throughout the migration toolkit, but I'm also going to provide resources at the end of this slide deck that has a link to it. And the last component for 3 to 6 migrations is the migration validator. So this is a post-migration or mid-migration. It's a command line tool for validating that your content was actually moved over correctly from 3 to 6. So really handy little tool that you can use to dig in kind of during or after the fact. So that was 3 to 6. Fedora 4 to 6 migrations are a little bit more tricky. Obviously still completely possible. We do have users that are working through this migration process as we speak. And while it certainly has a few more steps involved than something like a 3 to 6 migration, it's not impossible. And I can't really stress that enough. It is doable, and people are actively working on it. So for Fedora 4 migrations, they would require an upgrade to 4.7.5 first. And the reason for that is to align the software with important components that were related to the API and updates to ModeShape to get it to, the most current, even though it's outdated, but the most current version of ModeShape. But once at 4.7.5, we do have a tool available, the import-export utility, and you would need to export your repository to disk. And from there, you will run the secondary tool, the upgrade utility, to upgrade your 4.7.5 export. You're going to upgrade it to a 5.1.1 export. Then you're going to rerun that upgrade utility, making some slight adjustments to your parameters to upgrade that 5.1.1 export to a Fedora 6 compliant OCFL. And then you're going to start up your new Fedora 6 and point the newly created OCFL from the newly created OCFL from the previous step. So it sounds like a lot of words, but not to worry. This is really all documented on the Fedora Wiki, along with links to all the appropriate tooling. And like I said, I'm going to share this with a slide deck with you, and then you'll be able to reach out if you have any questions. But this is the pathway from 4 to 6, and we really are looking to gather more use cases as we hear about more people undergoing this migration process. In touching on Fedora 4 migrations, what we've learned is that a large portion of our Fedora 4 users come from the Samvera community, specifically their Hyrax users. So some of the work that we're doing right now is actually directly related to the Samvera community through our participation and collaboration in the Hyrax Fedora 6 working group. I don't really have enough time to go into all the specifics about how this group was formed and kind of why, but from a high level, the goal here is to support Fedora and Samvera communities together for users who want to to see an upgrade from Fedora 4 to Fedora 6 in their technology stack, and obviously the most up-to-date version of Hyrax. So this working group first started meeting in late summer and officially formed in September. The group consists of stakeholders that are interested in seeing a functional migration pathway for Hyrax users that are currently on Fedora 4 to get to the most up-to-date version of Hyrax backed by Fedora 6. So there's a lot of exciting advancements happening here in the Samvera community on this exact pathway, including a new Hyrax 5 release candidate, or RC. There's also a Docker image called Sirenia, which is Hyrax 5 backed by Fedora 6, which is available for testing. So as you can see, there is a lot of great progress happening on this work, and we're very excited to see that working group through. That's unfortunately all the time I have for today. I do really appreciate the opportunity to come and share this information. If you have any questions, please reach out. Here's my email. We would love to hear from you. And then here are all the resources as promised. And again, I'm going to share the slide deck with the MIRL organizers. Thank you for having me, and I look forward to seeing you.
Welcome, and thank you for joining me to learn about the open research infrastructure best practices and programs that are available through Lyrasis. Open research infrastructure can be defined as technical components that can be used within or alongside various software systems to enable assessment, openness, and fairness in the research and scholarly communication ecosystem. You may have heard of the FAIR principles, which traditionally refer to making research data more findable, accessible, interoperable, and reusable. The FAIR principles can actually be applied to any type of research or scholarly output, and even information about research. Ultimately, open infrastructure lays a foundation for gauging the extent and reach of researcher activity. At Lyrasis, we currently support 3 open infrastructure programs that are designed to help with this: the IRIS US community, the Lyrasis DataSite US community, and the ORCID US community. IRIS stands for Institutional Repository Usage Statistics. IRIS is an aggregation service for gathering, sharing, and exposing counter-based usage stats down to the individual item level within a repository. IRIS is based at JISC in the United Kingdom, but Lyrasis manages a program for US institutions that want to take advantage of the service. IRIS uses counter-based statistics, an international standard that ensures vendors and publishers can provide their library customers with consistent, credible, and comparable usage data. For example, libraries already get counter stats from their paywalled electronic resource publishers to see how many people are using those resources. And the counter stats provided by IRIS allow us to get a better idea of the usage of local materials in an IR. Organizations that are members of the IRIS US community get a special tracker code that gets added to your repository, which tracks the number of times landing pages and items get clicked on and downloaded, filtering out any spiders or bots. And this usage data gets sent to the IRIS server, where it's processed into counter-conformance stats and then made visible via reports and visualizations in the IRIS portal. IRIS allows for reporting at the overarching repository platform level, as well as reporting based on item type, including item investigations, which is someone just landing on the item page, and item requests, which is someone downloading the item. If you have ORCID IDs for authors in your repository, IRIS can provide stats for all items from a specific author. And if you have DOIs assigned to items in your repository, IRIS can provide item level stats based on DOI. IRIS data is open for anyone to see, and IRIS stats can be benchmarked against peers. This screenshot from the IRIS site shows the top 20 most used items in the month of March 2023 across all repositories that are using IRIS across the globe. The top item here is from the University of Michigan's Deep Blue repository with over 7,000 item requests. So you can start to see how this service might be helpful for gauging how widely your repository items are being used and how this compares against similar items in other repositories. IRIS works with all of these different software systems, and if you want to use it with a system that you don't see listed here, let us know and we can find out the status for you. The Lyrasis DataSite US Community Program was started in 2021 as a DataSite consortium for nonprofit organizations in the US who want to assign DOIs to local research and scholarly materials. DOI stands for Digital Object Identifier, and DataSite is a global nonprofit DOI registration agency that allows organizations to assign DOIs to their local content. Things like data sets, electronic theses and dissertations, open educational resources, data management plans, and so much more. DOIs help us to avoid the 404 page not found error when it comes to accessing research and scholarly resources online. A DOI is basically a unique link that is designed to point to information about an object persistently over time so that the object can always be accessed. When a user clicks on a DOI link, the DOI system looks up the metadata associated with that DOI and redirects the user to the URL or landing page where they can find information about the object as well as how the object can be accessed. All DOIs contain open metadata about the objects they are assigned to, such as who created it, when it was made available, and where it can be found. This makes the objects more fair. DataCite DOI metadata is indexed in multiple databases: Clarivate's Data Citation Index, Mendeley Data, Dimensions, XLibris Primo, ProQuest Summon, Google Dataset Search, OpenAir, as well as in DataCite Search. Several software systems already have the DataCite API built in or have a plugin that can be used to assign DataCite DOIs to objects in a repository. And DOIs can also be created manually in one-off cases outside of a repository as needed. The ORCID US community is a consortium for nonprofit organizations that are ORCID members in the US. It was started in 2018 and has grown to include over 200 organizations. ORCID stands for Open Researcher and Contributor Identifier, and ORCID is a nonprofit, community-driven organization that serves the entire global research community. An ORCID ID is a free, unique, persistent identifier for researchers or individuals that links to an ORCID record where information about that individual can be stored, similar to what you would see on a resume or CV. And ORCID provides an API as well that can be used to transfer information between an individual's ORCID record and institutional systems. For example, researchers who are receiving grant funding are increasingly asked for their ORCID ID and able to use data from their ORCID record to populate grant application forms and progress reports. All of the US federal funding agencies are currently in the process of setting policies related to grant recipients having an ORCID ID and using their ORCID record for disclosures during the application process. Researchers applying for funding from the National Institutes of Health or the National Science Foundation can already use their ORCID record to populate their biographical sketch through Science CV. And we're expecting to see more of this kind of initiative from other federal agencies as well. It's really becoming a best practice to use persistent identifiers like ORCID and DOIs at every relevant stage of the research lifecycle. Even the White House Office of Science and Technical Policy, in their memo on public access to federally funded research, talks about digital persistent identifiers being used for researchers, which is ORCID, and research outputs, which is generally DOIs. So we can expect to see more policies and requirements regarding persistent identifiers as the federal agencies implement their policies related to these memos. ORCID is being used increasingly in funding and grant management systems, but also publishing, repository, and research information management systems. The software systems that you see on this slide all have the ORCID API built in or readily available, allowing users to connect their ORCID ID with these systems and import data from their ORCID record and or export data to their ORCID record. And if you're interested in data visualization, this map shows 2022 publication collaborations between researchers at Caltech and other parts of the world. We were able to create this visualization using public data from ORCID records and DOIs, and we have resources available for anyone to create a similar visualization of collaboration activity at your own organization. This is just one example of the type of data that can be gathered and visualized based on open metadata from ORCID records. So to summarize, we have ORCID to identify researchers and gather, analyze, and visualize researcher affiliations and activities. We have DataCite DOIs to make works findable, accessible, reusable, and trackable. And IRIS to gather repository platform and item interaction stats for assessment and benchmarking. If you have any questions, I would love to hear from you. Please email me at sheila.rabun@lyrasis.org. Thank you.